In this video, we're going to explore Venn diagrams. Venn diagrams are a visual way of displaying the relationships between different sets and different groups. So, for example, let's look at the top chart here. When we have a set that's called P and another set called Q, when all elements of P are also elements of Q, that's how we write if P, then Q, right? In conditional statement, if P, then Q. If I'm an element in P, I must be an element of Q. And in English, we often express with all, always, everything, those kind of very inclusive keywords. And the diagram is shown as what you see here. Let me get a different color. So for P, I have a yellow color, if I can erase the outside a little bit. And then for Q, I have everything, including the yellow. I didn't do the yellow right. There we go. Okay, so that's how we use diagrams to display if P, then Q. Now, what if some elements in P are also in Q, but in Q, there's some elements in Q that are not in P. So that's the second diagram when we say if this on the left, this is P, on the right is Q, where they overlap here is P or Q, right? They're either in P or Q, and together, everything in P and everything in Q is this whole, both circles together. And sometimes there's no relationship at all between P and Q. They don't overlap at all, and that's the third scenario that you see here. Oops. There we go. And some keywords to pay attention to. So let's look at some practices here. We're asked to draw a diagram to represent each element. Here it says some students who take chorus here. Some students who take chorus also take band. So we have probably students who take chorus, if we call that P, students to take band, we call that Q. So we can say P is here, Q is here. And obviously, sometimes a student takes both are included as well. So, or you can just say this is chorus, this is band. Okay. Number 2, no perfect squares are prime numbers. So we have two groups, two sets, perfect squares and prime numbers. So we can say in this circle, this is perfect squares. And this circle is prime numbers. They don't overlap at all. Number 3, numbers divisible by 6 are always divisible by 3. So the key word is here. So if we have a number divisible by 6, if we call this P, and those divisible by 6 and call that Q, and we have a relationship like this. So P is divisible by 6, right? And Q is divisible by 3. Number 4, every natural number is a whole number. So we have natural number, and that we call P, and whole number we call Q. So we can simply say P is here and Q is here, right? Because whole number is 0 and all the natural numbers. Number 5, some vertical angles are complementary. So some is our keyword. So if we call vertical angles as P, complementary angles as Q, so we can do P here and Q here. And what's overlapping there are those vertical angles that are also complementary. 90-degree vertical angles are also complementary. They are a small portion of the two sets. Number 6, irrational numbers are never rational numbers. So complete opposite, and the key word is never. So if we call this P, we call this Q, we would have P on one side and Q on the other side. Number 7, shade the indicated region on the Venn diagram. So Q, we're looking for Q, so this whole circle is Q, right? All the elements in Q are in this golden part. See if I can do this. There we go. That's my Q. Now P and Q. So this is the portion that's in both P, that's in both P and Q. That's where they overlap. P or Q, so these are the elements that are either in P or in Q, so that includes everything. So I can probably do, ooh, that's really perfect, isn't it? There, that's pretty good. If I can erase this a little, there we go. That's pretty perfect. That's P or Q. And number 10, all the elements that's in P and not Q. So first let's see, if I'm in P, it's all Q, all there, right? But there's a portion in here, that there's this portion here, that's in P, but also in Q. So I have to erase that because I don't want anything in Q. So, so the way to do it, let me fix this first. So the way to do it is to shade the area that's in P, but do not shade anything that's in Q. So let's see, I'm going to use this. These are the elements that's in P, right? But it's not in Q. See if I can shade it with my highlighter a little bit closer. Not too bad, not too bad. Not too bad. That's good enough. You got the sense there. So next, describe each diagram using a conditional or compound. Remember, conditional is if then, compound is and. So number 11, I've got acute angles that measure 60 are always acute angles. So if I use a conditional statement, I say if an angle measures 60 degrees, then it is an acute angle. Number 12, all the beagles are also dogs, right? So if an animal is a beagle, if an animal is a beagle, then it is a dog. Number 13, there's a circle of people who play volleyball, and there's a circle of people who play piano, and they intersect. So that means some people play volleyball and take piano lessons. Okay. Number 14, the shaded part is all in months with 31 days. So the months that start with J. So the opposite of that is do not. So number 14 is the months with 31 days and do not start with J. Number 15, the shaded part is freshman, but not in a art class. So we say students who are freshmen and do not take art classes. Finally, number 16, everything included. So that's numbers that are multiples of 7 and even numbers. I'm not going to write it out again. You just add the two together. That's numbers that are multiples of 7 and even numbers is the answer to 16. Okay, I'll make a separate video for the additional practices for your reference, but this is the basics of Venn diagram. Thank you guys. Bye.